Okay, I'm going to bang through some questions real quick. I'm just going to use straight out the textbooks. I'm not going to write anything per se. I'm actually just going to write here for question one. Now, if you really think about it, there's only like 4 different types of graphs that they can show you, and you've just got to think about it and which one's going to be. And you can just be a little bit sneaky and clever, and if you kind of know your 4 graphs and how they're increasing, decreasing, you can say a lot. So here's our first one. Now, I would say this is probably the hardest question to get you going. Everything else, once you've mastered this question, everything else is a little breezy, I would say. I wouldn't say it's too hard. Now, for each curve, describe the sign dy dx and d to the power of 2y dx to the power of 2. So the first differentiation, the second differentiation. We can kind of do this quickly, or we can sit and think about it and come to a logical conclusion. Let's try and do it quickly, knowing our rules, but also thinking about it as well. Let's try and do both for this question, so it'll build your understanding, make your memory a little bit better, and you can solve questions easier. So here, well, if we're looking at this curve, okay, and we were to give the gradient at any point, if we were to choose any point along here, it would be a positive value. If we just went, okay, I'm choosing this point, it would be a gradient like that. That's an increasing gradient. That's a positive gradient. So we can say, oh, well, anywhere along here, it's going to be greater. So this must be greater than 0. Then we can also look at our second curve. If we're differentiating this line anywhere along here, or this is kind of knowing our rules a little bit, is this going to be concave up or concave down? Well, it's going to be concave up. Okay, so if that's the case, then our second differentiation will be positive. Even if we were to doing this as a parabola, let's just say, I don't know, it's going to be y equals, it's going to be some number below, x squared minus 1. Let's say it was that. If we differentiate this twice, once is going to be 2x, and double is this going to be 2, that is above 0. That's going to give you a positive value no matter where it is, because this is some kind of parabola in this local section. So we know, just by looking at this and knowing our rules, that this is going to be positive. That's all there is really to it. If we're looking at C and E, I'll do these ones for you. Well, looking at this, well, this is increasing, but it's decreasing in how much it is increasing. Ugh, that's a tongue twister. If you think about it, it's leveling off. Okay, it's still increasing, but it's leveling off. So our first derivative, if we take any point, they're all going to be positive. They're all going to be positive at any point along this curve. So we know this is greater than 0. However, knowing our understanding from a previous exercise, this is going to be concave down. Therefore, the rate of it increasing is decreasing. Okay, so therefore, this must be less than 0. That's a really good question. If you can understand that, you're really on your way to mastering this topic. And our third one down here, well, okay, so it is, well, this is exactly the same as this one up here. It's just a different place. So we know that's going to be greater than 0, and that's going to be greater than 0. It's going up at any point, and it's also concave up. So they're both positive. Now, I am just going to quickly smash through some of these questions. The curve below shows the population of a colony of seals. Describe the sign of the first and second derivative. Okay, so it's going to be the same as our C. Our dy dx will be positive. It's increasing. The population is increasing, but the rate of it increasing is declining. It's steadily going out. How is the population rate changing? Stabilizing. I can't spell, but whatever. Question 3 I'm going to skip. It's going to be very similar to question 4. Draw a sketch to show the shape this. Now, I just realized 1, 2, 3, 4, there's 4 different types of graphs that we can use. I'm just going to pick A. A is actually this one here. If fx is decreasing, okay, so it's going to be negative, so it's going to be going down, or the things are going to be pointing down like that, it's going to have this type of curve. And if x double dash is less than 0, again, it's going to be concave down. So for 4a, it's actually this curve here is 1b. And I'm going to skip down to this. The size of class at the local TAFE college is decreasing, and the rate at which this is happening is decreasing. Now, I do not like this question, but it's a little bit of a, I don't know, it's a bit misleading. I think the first part makes sense. The size of class at the local TAFE is decreasing. Okay, that's easy. Well, that tells us f-x is less than 0. And the rate at which this is happening is decreasing. That means the second derivative is also it's changing as well. So that means that that one is positive. So I think, and I'm pretty sure 1D answers this question, sizes are decreasing, however the rate at which it's happening is decreasing. Okay, so that means it's actually a positive value. It's going to be curved up. This question is very misleading in its way. You've really got to understand the language of which it's saying. The language of which it's trying to convey, but it's also trying to trick you. Because there's only so many ways you can make 4 graphs up here. So they've got to come up with some kind of question like this. So keep an eye out. Don't be tricked. Try and do one more. Okay, I'm going to skip to question 10. The graph shows the number of students in a high school over several years. Okay, so students are kind of leaving. This is similar to what we're having at our school at the moment, where students are slowly leaving. Describe how the school population is changing over time. Include the rate of change. Okay, so students are leaving, and they're leaving very quickly over time. Okay, so it's getting worse and worse. So I don't know, maybe the school's got a bad culture or something. So we would say it's going to be concave down. So I know my second derivative is going to be like that. And I know my first derivative, it's all going to be negative as well. So I know dy dx will be less than 0. All these will be negative. And my d2y dx2 will also be negative because it's concave down. That's all I've got to say. Those are the questions. It's not really that hard to do once you get the ball rolling. However, thinking about it can be challenging. Just try and work through it. Those real-world examples I gave you at the start are probably the best getting the ball rolling and thinking about your brain and how to approach this. But it is a little bit challenging going and doing this. Okay, so take your time, don't freak out, don't stress. If you have any problems, talk to each other, or you can even contact me through Edmodo.